Hello, this is question 1 on your June 2022 paper from Edexcel, the statistics paper, where George throws a ball at a target 15 times. Each time George throws the ball, the probability of the ball hitting the target is 0.48, and the random variable x represents the number of times George hits the target in 15 rounds. So we can say, to start with, that that variable x is going to be a binomial because we are repeating the experiment or the event 15 times, which is fixed. Probability of success is 0.48. We have success, which is hit the target, failure that is not hitting it, and the rows are independent. We have to find probability of x being equal to 3. So we just have to go to the calculator with binomial PD. So for this one is binomial PD because it's probability distribution. Binomial is a particular value, so equal to a number. N is 15, x is 3, and p is 0.48, and then you get your value, and your value is, just in case you want to check, this thing here, and we can round, let's say, to 4 decimal places. Is a good rounding for probability questions. 1, 2, 3, 4, 7. Yeah, 4 decimal places. Then for the second part, they ask probability of x being greater or equal than 5. So for the second part, x being greater or equal than 5. We are going to use now binomial CD, cumulative, because I have the equal, the greater, or the smaller CD. But remember that in binomial CD in the calculator or in the tables, because this is tabulated, we have the smaller or equal. So we have to rewrite this question with a smaller or equal, because that's what we have in the calculator. And this is 1 minus probability of x being smaller or equal than 4. Yeah. And now we go to the calculator. X is 4, n is 15, p is 0.48. And we find that value, which is 0.0798 more, and this is 0.92013. Again, we round to 4 decimal places, so 0.9201. Yeah. So these are my first 2 answers, this one and this one. Then George now throws the ball at the target 250 times. Use a normal approximation to calculate the probability that he will hit the target more than 110 times. So for B, we need to find the probability that x is greater than 110 times. Yeah, but we are approximating x by a normal distribution. Let's go to call it y, just to call it differently. And this normal distribution, the mean is going to be the mean of the binomial distribution, which is MP, and the standard deviation is going to be square root of NP 1 minus p. If you don't remember this, it's in the formula booklet, a bit hidden, so let me show you. This is your formula booklet. So in A-level maths, not in AS, when you go to statistics, you have the discrete distributions, and they give you the mean of the binomial and the variance of the binomial. So this is where we are using to approximate the binomial by a normal distribution. So MP is 250, because now I have 250, and the probability of success 0.48, and this is 120, and this is square root of 250 times 0.48, and then times 0.52, and this is the square root of 624. So my normal distribution is going to be 120. Remember, I write here the variance, while in the calculator I put the standard deviation, so I don't write the root here, but I use the root in the calculator. So I need to find this probability. This probability is going to be approximated by the probability of y, which is now a normal distributed variable. And remember, when I approximate a discrete distribution, which is binomial, by a continuous distribution, which is the normal, I'm going to introduce a continuity correction, which is 0.5 up and down. In this case, I want greater than 110, but not the 110. So I'm going to write that y must be greater than 110.5. Yeah. If I have the equal here, for example, I will have to write 109.5. So it's going to be always 0.5 up and down. So I include this value or I don't. If I don't want to include it, like is the case, I'm going to start a bit farther up. And then I go to my calculator, normal CD, cumulative distribution. My lowest value is this one. My higher value, you can pick any very large number. So I suggest something like 99999. It doesn't need to be that large, but the mean is 120 and the standard deviation is the square root of this value. Yeah, and if you do that, you get 0.88544. If we round to 4 decimal places, we are leaving something like this: 1, 2, 3, 4. Yeah, and that's it with this exam question. So this is the last answer that you have.